Good afternoon, sir. I am Saksham Paliwal from Branch Mathematics and Computing, IIT Delhi. So today I am going to present an electrical project. So I have made the electrical project on rectifier circuits. So rectifier is a device used to convert AC signal to DC signal. Rectifier circuits is one of the most important applications of diode. A representative block diagram in the following slides will show that how a DC power supply is provided in houses and the role of rectifier circuits in it. So this is an overall system of how the power supply is supplied in the home. Initially, we have a power transformer, which is generally step down, and after it goes through a rectifier, which I'm going to present today, and then it goes through a filter circuit and a voltage regulator to our homes. So initially, if it is it is a sinusoidal wave, rectifier circuit converts it only into direct currents, and then filter circuit makes it almost constant, and regulator make it constant voltage. So types of rectifier circuits, these are three basic rectifier circuits that we have studied in our classes. So first is half-wave rectifier. The half-wave rectifier utilizes alternate half cycles of the input sinusoid. This circuit cannot be used to rectify an input sinusoid of 100 millivolt amplitude. For such an application, one resorts to a so-called precision rectifier, a circuit utilizing diodes in conjunction with op-amps. So this is the circuit. This is a diode with a VD cut-in voltage. So when VS is pointing towards the diode, and diode is forward biased, so the current will flow through it, and uh, we can see that if it is a sinusoid, then initially if Vs is this black curve, then the output voltage VO is this blue curve, and when the black curve tends to become negative, the D becomes reverse biased, and hence no current flows through it and no voltage output is received. Hence, we can see that the blue line is zero when the black line is negative. Also, there is some gap between the black line and blue line. That is because of the VD, that is the cut-in voltage, that is uh, like approximately 0.7 volts for a semiconductor diode. So this explains the graph, and we can see now that it has become a direct current because all are positive and are of same sign. So next is a full wave rectifier. Full wave rectifier utilizes both halves of the input sinusoid. Like we have seen in the half wave rectifier, only half wave was rectified. So it obviously provides greater efficiency. And here the secondary winding is center tapped to provide two equal voltages Vs across the two halves of secondary winding with polarities indicated. So this is the full wave rectifier, and this is center tapped. So when there is an AC voltage line, if these both, this is positive side, then this also will become the positive side. And when this is positive and this is negative, this diode will become forward biased, D1 will become forward biased, and hence the current will flow through this one. But if the dot becomes negative, when the curve is negative, Vs becomes negative and the D1 diode becomes reverse biased, but the bottom diode, that is D2, this becomes forward biased. Hence, the current is approximately the same. The curve will be same almost. And this is a way through which we can, like it is two half-wave rectifiers in opposite direction, which is a nice way to make the full wave rectifier. And we can see here the same curve, and the gap is again due to the VD voltage drop in the diode, and this is V naught versus Vs. So it is directly proportional because V naught is IR. Another rectifier is the bridge rectifier. This circuit known as the bridge rectifier because of similarity of configuration to that of the Wheatstone bridge. It does not require center type transformer. The bridge rectifier, however, requires 4 diodes as compared to 2 in the previous circuit, but this is not much of a disadvantage, and that may not be the problem. Here we can see, uh, uh, like this is a kind of a beadstone bridge. When the top line is positively charged and negative is bottom is negative, bottom has negative potential, then we can see that D4 will be reverse biased because V5 that the middle point is grounded. So if the top point is positive potential and the um, middle point is has zero potential, then we can see that D4 is reverse biased. But again, D1 will be forward biased and a VD drop will we can see there. Then the current will flow through the resistor and then through the D2. As again the bottommost point has negative potential, then we can see that D2 is forward biased and D3 is reverse biased. So through the journey, we can see that there are two diodes in the region. So 2 VD will be the voltage drop here. And again, this is a nice way to make to use the full waves of the sinusoidal input curves. So yes, that was all. Thank you.